Now here the question is, a triangle has two of its sides along this axis and its third side touches this circle whose center is at a comma a and radius is equal to a. So this circle, it touches both the axes. Now we have a triangle whose two sides are along the axis and third side it touches this circle. Now suppose this is origin. Now let this point be P and this point be Q. So coordinate of this point is, suppose P comma 0 and coordinate of this point is 0 comma Q. Now this angle is 90. So circumcircle of POQ will have PQ as diameter and its midpoint will be center of the circle. We have to find locus of circumcenter. So let this point be alpha beta. Now since alpha beta is midpoint of PQ, alpha is P by 2 and beta is Q by 2. Now equation of this line PQ, so equation of PQ will be given by x upon P plus y upon Q equals to 1, and since this line is tangent to this circle, that means perpendicular distance from the center must be equal to its radius. We get a upon P plus a upon Q minus 1 upon under root of 1 upon P square plus 1 upon Q square, and it will be equal to A. Now we can simplify this as A P plus Q minus PQ and be equal to A under root of P square plus Q square. Now we square it, we can write A square and there will be P square plus Q square plus 2PQ plus P square Q square minus 2APQ P plus Q, and that will be equal to A square P square plus Q square. Now A square P square plus Q square will cancel. So we'll get this as 2A square PQ plus PQ square minus 2APQ into P plus Q, and that will be equal to 0. Now here PQ will also cancel. So we'll get this as 2A square plus PQ minus 2A P plus Q equals 0. Now P is 2 alpha and Q is 2 beta. So we can write this as 2A square plus 4 alpha beta minus 2A 2 alpha plus 2 beta equals 0. So it will be this A square plus 2 alpha beta minus 2A alpha plus beta equals 0. Now we'll replace alpha with x and beta with y. So this required locus, it will be A square plus 2xy minus 2A x plus y equals 0. Now locus of circumcenter, it passes through this point which is 38 comma minus 37. So it will be this A square plus 2 into 38 into minus 37 minus 2A equals 0, or A square minus 2A equals 2812. So answer to this question is 2812. Now here the question is, from a point P on the circle with center O, chord PA 8 cm is drawn. The radius of the circle is 24 cm. Let PB be drawn parallel to OA, and suppose OB extended meets PA extended at M. The length of MA is 9 cm. Now for this statement 1, we have this circle with center O, and suppose we have this chord AP. So this is A. So we have this point, say P here. Length of AP is 8 units, radius is 24, and it says PB is drawn parallel to OA. So we have drawn this PB, which is parallel to OA. Now BO extended. So we have extended this BO and it meets extended PA at this point M. Now it says length of MA is 9 centimeters. Now this is 24 and if we draw perpendicular here and here and say these points are Q and R. Now suppose this AR, it is X, then OR is 24 minus X, and so is PQ. So this PQ is 24 minus X, and this is radius, so this is 24. Now in this triangle we can write OQ square as 24 square minus 24 minus X whole square, and this OQ square, it is equal to PR square, which from this triangle ARP we can write 8 square 64 minus X square. Now it will be 48X minus X square, and there will be 64 minus X square. So this X square will cancel. So this X will be 4 by 3. So value of X is 4 by 3. Now in this triangle MPB, O is parallel to PB. Then we can write MA upon MP will be equal to OA upon BP. Now we can also write this as MA upon MP minus MA, and it will be equal to OA upon BP minus OA. Now MP minus MA is AP, so we can write MA upon AP, and that will be equal to OA, and OA is simply 24 upon BP. BP is 2 times 24 minus X minus OA, which is 24. Now AP is 8, so we can write MA upon 8, and it will be equal to 24 upon, and this is 24 minus 2 into X, and the value of X is 4 by 3. So it will be this MA by 8, and if we divide everything with 8, it will be 3, and then 9 minus 1, 8 into 3. So value of AM is simply 9 centimeter. That means this statement 1 is correct. Now statement 2 is OA is radius of the circle with center at O, and R is point on OA through which a chord CD perpendicular to OA is drawn. Let a chord through A meets the chord CD at M and circle at B, and also OS is perpendicular from O on chord AB. If the radius of circle is 18 centimeter and R is the midpoint of AO and AM upon MB is 1 by 2, then length of OS is 9 centimeter. So now we'll draw conditions given in the second statement. So for this second statement, we are given a circle whose one of the radiuses OA. So this is O and this is A. Now there is a point R on OA through which a perpendicular chord CD is drawn. So we have this perpendicular chord CD which is drawn through this point R. Now there is another chord which passes through A and which intersects the circle at B. So this point is B and it intersects CD at this point M. It says OS is perpendicular from O to chord AB. So we have OS, which is perpendicular to this chord AB. Now it says if the radius of circle is 18 centimeter, so we have OA as 18 and OB as 18 and AM is to MB, it is 1 by 2 and this R is midpoint of OA. So basically this OR, it is 9 and RA is also 9. So OR equals RA and it is equal to 9 and AM is to MB is 1 is to 2. That means this AM is 1/3 AB and AS is 1 by 2 AB since it is perpendicular from the center. Now we'll prove that these two triangles, triangle ARM, it is similar to triangle ASO. So this angle A is common, angle ARM is equal to angle ASO. So from AA property, these two triangles, they are similar, and if they are similar, then AR upon AM will be equal to AS upon OA. Now AR is 9 and this is AM, this is AS and OA is 18. Now AM is 1 by 3 AB, so it will be 1 by 3 AB into AS is 1 by 2 AB and it is 9 into 18. So this AB will be 18 root 3. Now AS is half of AB, so this AS will be simply 9 root 3 and then in this triangle OSA we can write OS square will be equal to OA square minus SA square and OA square is 18 square minus 9 square into 3. Now this is 9 square into 4 minus 3 1, so it will be equal to 9 square. So basically value of OS is 9 centimeter. So length of OS is 9 centimeter. That means this statement 2 is also correct. Now figure 2 is no way close to figure 1. So these two statements are correct independently, and answer to this question is both the statements are correct, but statement 2 is not a correct explanation to statement 1. That is, answer to this question is this option B. Now here the question is lines 5x plus 12y minus 10 equals to 0 and 5x minus 12y minus 40 equals to 0 touch a circle C1 of diameter 6. If the center of C1 lie in the first quadrant, find the equation of circle C2 which is concentric with C1 and cuts an intercept of length 8 on these lines. Now what we'll do is first we'll draw these two lines roughly on coordinate plane. So this first line is 5x plus 12y plus 10 equals to 0. So here x-axis intercept is 2 and y-axis intercept is little less than 1. So it will be this line. So this is 5x plus 12y minus 10 equals 0. Now for the second line, x-axis intercept, it is at 8, 0 and y-axis intercept is at 3 point something but in the negative axis. So this line will be drawn something like this. Now slope of this first line, it is minus 5 by 12 and slope of the second line, it is 5 by 12. So basically these two lines, they'll make these equal angles. Now a circle whose center is in the first quadrant and which touches both the lines will have its center along this angle bisector. And for this, we have to find x coordinate of their point of intersection. So if we add them, we'll get this as 10x minus 50 equals 0. So this line is x equal to 5 line. So center of this circle will lie at 5, k. Radius of the circle is 3 units. So this is 3 units. Now perpendicular distance from the center must be equal to its radius. So we'll get 25 plus 12k minus 10 upon 13 and it'll be equal to 3. So we'll get this as 12k plus 15, it is equal to 3 into 13 or 4k plus 5 equals plus or minus 13. Now we need the center in the first quadrant. So we'll take plus sign. So we'll get 4k equals 8. So value of k is 2. So center of this circle, it is at 5, 2. So this center, it is at 5, 2. That says we have to find equation of the circle C2, which is concentric with C1. So that means for this circle C2, center is again at 5, 2. Now this C2, it cuts an intercept of length 8 on these lines. So this C2, it cuts an intercept of 8 units on each of these lines. So we'll take this one line, 5x plus 12y minus 10 equals 0. This is 5 by 2. Now, perpendicular distance from the center, it is 3. So this distance will be 3. And this length is 8. So this length will be 4. That means radius of this circle will be 5. So we have to find this circle C2 with center at 5, 2 and radius equals 5. So equation of this circle will be x minus 5 square plus y minus 2 square, and that will be equal to 25, or we can write x square plus y square minus 10x minus 4y plus 4 equals 0, and that is the answer to this question. Now here the question is, a circle passes through the point a comma b and cuts this other circle x square plus y square equals to k square orthogonally, then equation of locus of its center. Now we will find equation of locus of its center. So let this point be alpha comma beta. Now for this other circle, center is at origin, and here radius is say r and this radius is k. Now this is C1 and this is C2. Now since these two circles, they intersect orthogonally, we know that C1 C2 square is equal to r square plus k square. Now C1 C2 square is alpha square plus beta square, and we can write radius of this circle in terms of alpha, beta and AB. So we're going to write this as alpha minus a square plus beta minus b square plus k square. Now here alpha beta, they'll cancel. So we'll get a square minus 2a alpha plus b square minus 2b beta and plus k square, or this required locus is 2a alpha plus 2b beta minus a square minus b square minus k square equals to 0. Now in the end, we'll replace alpha with x and beta with y. So we'll get this equation as 2ax 2by and then minus a square plus b square plus k square equals 0. And that's your option A. Now Now it says the two circles intersect in two distinct points. Now we know that two circles, they'll intersect at two distinct points if C1, C2, it is greater than mod of R1 minus R2 and it is less than R1 plus R2. Now here C1 is 1, 3 and C2 is 4, minus 1. R1 is R and R2 is 16. 16 plus 1, 17. 17 minus 8, 9. So this radius is 3. Now this is mod of R minus 3 and will be less than C1, C2. Now C1, C2 is 3 square plus 4 square, which is 5. And then R1 plus R2 is R plus 3. So from here we can say this R, it must be greater than 2 and mod of R minus 3 will be less than 5, then minus 5, R minus 3 should be less than 5 or R should lie between minus 2 and 8. Now R cannot be negative and R is greater than 2. So the condition that we get from here is value of R must lie between 2 and 8, and that's your option A. Now here the questions. Let ABCD be a quadrilateral with area not K. This area is actually 18. So with area 18 with sides AB parallel to side CD and AB is 2 times CD. Let AD be perpendicular to AB and CD. If a circle is drawn inside the quadrilateral ABCD touching all its sides, then its radius is. So we have this circle which touches 4 sides of a trapezium, and this is A, B, C and D, and this is 90. This angle is also 90, and area of this trapezium ABCD, it is given as 18 square units. Now suppose this is the center of this circle. Now this is R, this is R, and this is also R. So this is R, R and R. Then basically AD, it is 2R. Now this is R and this is also R. And this is perpendicular. Now length of CD is say X. It is given that AB is 2 times CD. So length of AB is 2x. So basically this distance, say PC, it is x minus r, will also be equal to this distance, and length of BQ, it is 2x minus r. Now first we'll write this area of ABCD. Now area of this trapezium will be 1 by 2 and then sum of parallel sides. So it will be simply 3x into perpendicular, which is 2r, and it is equal to 18. So we'll get this condition that 3xr and it is equal to 18, or we can write x into r equals 6, and that's our first equation. Now here what we'll do is we'll join now suppose this is alpha and this is theta. Now if we write tan alpha will be x minus r upon this value r, and we can write tan theta, and tan theta is this value 2x minus r upon r. Now we know that theta plus alpha, it is pi by 2. Then basically tan theta into tan alpha, it should be 1. So we multiply them, then we can write x minus r into 2x minus r upon r square will be equal to 1, or 2x square minus 3xr plus r square will be equal to r square. So from here we get either x is 0 or x is 3r by 2. Now x, it cannot be 0 as it is side of this trapezium. So we'll put x as 3r by 2. So we'll get this as 3r square by 2 equals 6, or value of r is simply 2. So answer to this question is option B, r equals 2. Now here the question is, tangents are drawn from a point 17,7 to this circle x square plus y square equals 169. Now statement 1 is tangents are mutually perpendicular, and statement 2 is locus of point from which mutually perpendicular tangents can be drawn to the given circle is x square plus y square equals 338. Now we'll begin with the statement 2, and we know that locus of perpendicular tangents is director circle for this given circle, and if it is x square plus y square equals a square, equation of director circle is x square plus y square equals 2a square. So it will be 2 into 169, that is x square plus y square equals 338. That means this statement 2 is correct. Now if we look at this point P, 17,7, and if we put it in this equation, we get 17 square plus 7 square equals 338. Now 17 square is 289 and 7 square is 49. Now 289 plus 49 is 338. That means this point, it lies on director circle, and a tangent drawn from any point on director circle to the given circle will always be perpendicular. That means this statement 1 is also correct. So statement 2 is correct, statement 1 is correct, and statement 2 is the correct explanation of statement 1, and therefore answer to this question is option A. Now here the question is, we have to prove that length of the chord of contact of the point P x1 y1 with respect to circle s equal to 0 is 2r under root s1 upon s1 plus r square. Now this s11 is same as what we call s1. So we have this circle, and we have a point from which tangents are drawn to this circle, and that's your chord of contact AB. So this point is A, and this is B, and this point P is x1 y1, and suppose this is your center C. Now this is 90, this is your radius r, and this is under root s1. Then we can write this theta, tan theta is r upon under root s1. Now this is tan theta, then its hypotenuse will be r square plus s1. So we can write sin theta as r upon under root r square plus s1. Now this is 90, and this is, suppose, AQ. Now AB is 2 times AQ, and AQ is AP sin theta. So it will be this AP sin theta. Now this is 2. AP is under root s1, and sin theta is r upon under root r square plus s1. So this is 2r under root s1 upon r square plus s1, which is what we need to prove in this question. Negative question is, if d is the distance between centers of two circles whose radius are r1 and r2, the length of direct common tangent is given by under root d square minus r1 minus r2 whole square, and length of transverse common tangent is given by under root d square minus r1 plus r2 whole square. So we have two circles. And first we'll talk about length of direct common tangent. Now this is line joining their centers C1, C2, and D is the distance between centers. Here we have to find this length of direct common tangent, say AB. Now we'll draw perpendiculars to the centers. Now this is R1 and this is R2. Now what we'll do is, from this center C1, we'll draw a line parallel to AB. And suppose this point is P. Now this is 90. This is 90. This AC1 PB, it is a rectangle. So if this is L, this is also L. Now this is R1. This is also R1. Then this distance will be R2 minus R1. Now this is a right angle triangle. So in this right angle triangle, we can write L square equals D square minus R2 minus R1 whole square. Now this L is AB. So from here we can write length of direct common tangent AB will be equal to under root of D square minus R1 minus R2 whole square, which is what we need to prove in this first part. Now in the second part, we have to prove length of transverse common tangent. Now if we have transverse common tangent between the two circles, this is C1, C2, radius is R1 and R2, and we have a transverse common tangent between the two circles. Now this is point A and this is your point B. Now we extend this a bit and from C1 again we'll draw a line parallel to AB, and suppose this point is P. Now this is 90, this is R1, this is R1, and this is R2. So this PC2 is R1 plus R2, distance between centers is D, and this AB, it is equal to L. So from here we can write this L will be equal to this AB, and it is equal to under root of D square minus R1 plus R2 whole square. So this is length of direct common tangent, and this is the length of indirect or transverse common tangent. And there is this one case which is also very important, and which is when the two circles, they touch each other externally. Now when the two circles, they touch each other externally, in that case, distance between centers D, it is given as R1 plus R2. So in this case, length of direct common tangent, say AB, will be given by under root of D square, which is R1 plus R2 whole square, minus r1 minus r2 whole square. Now here r1 square and r2 square will cancel, so it will be equal to 2 times under root of r1 r2. So if two circles they touch each other externally, then in that case length of direct common tangent it is given by 2 under root of r1 into r2. Now the question is number of lattice points that are interior to this circle. So we have this circle with center at origin, and its equation is x square plus y square equals 25. Now here this point is 5, 0 and this is minus 5, 0. So on this line where y equals to 0, the value of x can be plus minus 4, plus minus 3, plus minus 2, plus minus 1 and 0. So we'll have 9 points on this line. Now if we draw a line at y equals 1, now if we put y as 1, we'll get values of x, they'll be plus minus 4, plus minus 3, plus minus 1 and 0. So again there'll be 9 points on this line. Now for y equals to, we'll have x equals plus or minus under root 21, which again is 4 point something. So on this line also we'll have 9 points. If we take y equals 3, then this point is 4, 0 and this point is minus 4, 0. So out of these 9, 2 points they'll go out. So here we'll have 7 points. And for y equals 4, this is 3, 0 and minus 3, 0. Here we'll have 5 points. And from symmetry, all these points, they'll also be below x-axis. So total number of lattice points will be this 9 points for y equals to 0 plus 2 into 9 plus 9 plus 7 plus 5 for y equals plus minus 1, plus minus 2, plus minus 3 and plus minus 4. Now this is 12 and 18, 30, 30 into 2, 60. So total number of lattice points is 69. And that's your option B. Now the question is the set of values of C so that y equals mod x plus c, and this circle which is x square plus y square minus 8 mod x minus 9 equals to 0 have no solution. So what we'll do is we'll find the point of intersection. So we'll replace y with mod x plus c. So it'll be this x square plus, and then here will be this mod x plus c whole square minus 8 mod x minus 9 equals 0. So it'll be this x square plus c square plus 2c mod x minus 8 mod x minus 9 equals 0, or it will be this 2x square plus 2c minus 8 mod x plus c square minus 9 equals 0. Now this equation should have no solution. Now this is not a normal quadratic equation, it is a quadratic in mod x. So this equation will have no solutions in two cases. Case 1, if d is less than 0, if there are no real roots, or if d is greater than or equal to 0, but both the roots alpha beta they are less than 0. So if roots are less than 0, then mod x equals negative value will give us no solution. So these are the two cases possible. Now we'll evaluate this first case when d is less than 0. So it will be b square. So this is 4 c minus 4 whole square minus 4 2 into c square minus 9. It should be less than 0. Now this 4 and 4 will cancel. We get c square plus 16 minus 8c minus 2c square plus 18 should be less than 0, or we can write c square plus 8c minus 34 is greater than 0. Now we'll add 16 and we'll subtract 16. So we'll write c plus 4 whole square. It should be greater than 50, or mod c plus 4. It should be greater than under root 50. So here we'll have two conditions. Either c plus 4 it is greater than under root 50, or c plus 4 is less than minus root 50. So the condition that we get here is either c is greater than minus 4 plus under root 50, or c is less than minus 4 minus under root 50. So this is one condition. Now this other condition is when d is greater than equal to 0. Now d is greater than equal to 0 if c lies between minus 4 minus under root 50 and minus 4 plus under root 50, and both the roots are negative. That means sum of roots alpha plus beta is less than 0 and alpha into beta is also less than 0. Now in this case, sum of roots is minus b upon a. So it will be this minus 2c minus 8 upon 2. It is less than 0. That means c is greater than 4. And here alpha beta is less than 0. That means c square minus 9 is less than 0. That is, value of c should lie between minus 3 and plus 3. Now intersection of all these three conditions is 5. So basically this case is not possible for this quadratic equation. So answer to this question is either c is greater than minus 4 plus root 50, or it is less than minus 4 minus root 50. Now here the option given is this option D, which is c is greater than minus 4 plus root 50. Now here the question is, a circle with center at origin and radius equal to a meets the axis of x at points a and b. If p, alpha and beta are 2 points on this circle so that alpha minus beta is 2 gamma, where gamma is constant, then locus of point of intersection of AP and BQ is. Now we have this circle with center at origin and it meets x-axis at A and B, and its radius is a. So this a is a comma 0 and b is minus a comma 0. Now we have 2 points P and Q on this circle. Now P is characterized by this alpha, so this P is a cos alpha, a sin alpha, and this Q is characterized by beta, so it will be this a cos beta and a sin beta. Now it says alpha minus beta is given as 2 gamma, the locus of point of intersection of AP and BQ. So we have to find locus of point of intersection of BQ and AP. This point, and suppose this point is M, it is given by alpha beta. Now these points A, M and P, they are collinear. That means slope of AM must be equal to slope of AP. So slope of AM is equal to slope of AP. Now slope of AM is beta upon alpha minus A will be equal to minus A sin alpha upon A 1 minus cos alpha. Now this A and A will cancel. Now we can write this as 2 sin alpha by 2 cos alpha by 2, and this is 2 sin square alpha by 2. Now this 2 and sin alpha by 2 will cancel. So we can write beta upon alpha minus A, it is equal to minus cot alpha by 2, and that's our first equation. And the same way, B, M and Q, they are collinear. That means slope of BM must be same as slope of BQ. Now slope of BM is beta upon alpha plus A, and will be equal to A sin beta upon A 1 plus cos beta. Now here this is 2 sin beta by 2 upon cos beta by 2, and here it is 2 cos square beta by 2. Now here cos beta by 2 will cancel, so we'll get 10 beta by 2 as beta upon alpha plus A, and that's our second equation. Now in the question it is given that alpha minus beta equals 2 gamma, so we can write alpha minus beta by 2, it is equal to gamma, and if we take 10 both sides, then we can write 10 alpha by 2 minus 10 beta by 2 upon 1 plus 10 alpha by 2 into 10 beta by 2, and will be equal to 10 gamma. Now 10 alpha by 2 is A minus alpha upon beta. So we can write this as A minus alpha upon beta minus, and 10 beta by 2 is beta upon A plus alpha, and here it is 1 plus A minus alpha upon beta into beta upon A plus alpha, and it is equal to 10 gamma. Now if we simplify this, we can write this as A square minus alpha square minus beta square upon beta A plus alpha beta plus A beta minus alpha beta, and it is equal to 10 gamma. Now alpha beta will cancel, so we'll get this equation as alpha square plus beta square plus 2A 10 gamma into beta minus A square equals 0. Or we can write this as x square plus y square plus 2A 10 gamma into y minus A square equals 0. Now here the question is, a variable straight line through this point A is drawn to cut the circles at points B and C. So we have this circle x square plus y square equals to 1, and then we have this point minus 1 comma 1 which lies outside this circle. So this is your point A, minus 1 comma 1, and it intersects this circle at B and C, and there is any general point P on this line which is suppose at a distance R from A, and also let distance of B from A is R1 and distance of C from A is R2. Now we can write parametric equation of this line passing through A. So this equation will be x plus 1 upon cos theta equals y minus 1 upon sin theta, and will be equal to R. So coordinate of any general point P will be minus 1 plus R cos theta and 1 plus R sin theta. Now we need these points B and C which lie on the circle. So this general point, it will lie on this circle. So from here we can write minus 1 plus R cos theta square plus 1 plus R sin theta whole square, it is equal to 1. Then we square it, we'll get 1 plus, now R square cos square theta plus R square sin square theta will be 1. And then we'll have plus 2R, and here it will be minus cos theta plus sin theta, and it is equal to 1. And here we'll have one more plus 1. So this plus 1 and plus 1 will cancel. So basically we'll get a quadratic equation in R, and that will be given by R square plus 2 sin theta minus cos theta R plus 1 equals 0. Now this equation will have two real roots, R1 and R2. Now basically R1 into R2 will be 1, and R1 plus R2 will be 2 cos theta minus sin theta. Now we'll come to P in the context of this question, AB, AP and AC. So suppose we have this point P whose distance from A is R3. So now we can write coordinate of this point P as minus 1 plus R3 cos theta and 1 plus R3 sin theta, and we have to find locus of this point P. So since it is a locus problem, we'll take this point as alpha beta. So this point is alpha, this point is beta. So we'll get R3 cos theta is alpha plus 1 and R3 sin theta is beta minus 1. Now we can start solving the question. Now this first part is we have to find locus of P if AB, AP and AC, they are in AP. That means R1, R3 and R2, they are in AP. Now basically R3 is R1 plus R2 by 2. Now R1 plus R2 we have already worked out. This R1 plus R2 is 2 cos theta minus sin theta upon 2. Now this 2 and 2 will cancel. Now we multiply everything with R3, so we can write R3 square will be equal to R3 cos theta minus R3 sin theta. Now we can calculate R3 square by squaring and adding them. So it will be this R3 square, and we can write this as alpha plus 1 square plus beta minus 1 square. So it will be this alpha plus 1 square plus beta minus 1 square, and R3 cos theta, it is alpha plus 1 minus, and R3 sin theta is beta minus 1. Now we can write this as alpha square plus 2 alpha plus 1 plus beta square minus 2 beta plus 1, and there will be alpha plus 1 minus beta plus 1. Now plus 1 and plus 1 will cancel. So this required locus will be alpha square plus beta square, this plus alpha and then minus beta equals 0. So locus of this point P will be a circle whose equation is x square plus y square plus x minus y equals 0. Now it says D be the minimum distance of origin from locus of P. So we have to find minimum distance of origin from this locus. Now as we can see, this circle, it passes through origin, so its minimum distance is simply 0. So this A, it matches with P. So A, it matches with P. Now second part is AB, AP and AC, they are in GP. So for part B we have AB, AP and AC, they are in GP, that is R1, R3, R2, they are in GP. Now that means R3 square equals R1 into R2, and we know that R1 into R2 is 1. So basically it will be this R3 square equals 1 and R3 square is this value. We'll get this equation as alpha plus 1 whole square plus beta minus 1 whole square, and it is equal to 1. Now basically it is a circle whose center is at minus 1, 1 and which touches both the axes. Now we have to find minimum distance from origin. Now distance of center from origin, it is root 2 and its radius is 1. So this minimum distance, it is root 2 minus 1. That means this B, it matches with S. So B, it is going to match with S. Now this C is AB, AP and AC, they are in HP. So we have this C where AB, AP and AC, they are in HP, or R1, R3, R2, they are in HP. Now here R3 is 2 R1 R2 upon R1 plus R2. Now this is R3, R1 into R2 is 1 and R1 plus R2 is 2 cos theta minus sin theta. Now here 2 and 2 will cancel, so we'll get this as R3 cos theta minus R3 sin theta, and it is equal to 1. Now R3 cos theta is alpha plus 1 and R3 sin theta is beta minus 1 and it is equal to 1. So this required locus will be alpha minus beta plus 1 equals 0. So locus of this point P will be this straight line x minus y plus 1 equals 0. Now perpendicular distance from origin will be equal to 1 by root 2. So this C, it matches with Q. C, it matches with Q. And then AB, AP by 2 and AC, they are in AP. It says for this D, AB, AP by 2 and AC, they are in AP. That means R1, R3 by 2 and R2, they are in AP, or R3 is simply R1 plus R2. Now this is R3 and this is 2 cos theta minus sin theta, or we can write R3 square equals 2 R3 cos theta minus R3 sin theta. Now R3 square is alpha plus 1 square, and this is beta minus 1 square, and this is 2 alpha plus 1 minus beta minus 1. Now this equation will be alpha square plus beta square plus 2 alpha minus 2 beta plus 2, and here will be this 2 alpha minus 2 beta plus 4. Now 2 alpha 2 beta will cancel, so this equation will be alpha square plus beta square equals to, or locus of this point P is now this circle, which is x square plus y square equals 2. Now in this case, distance from origin is basically its radius, which is root 2. So now d is root 2. That means this d, it matches with r. So this d, it matches with r. So answer to this question is PSQR. Now here the question is, a ray of light is incident at a point -2, -1 and gets reflected from the tangent at 0, -1 to this circle. The reflected ray touches the circle. The equation of line along which the incident ray moved is. So we have this circle with center at origin, and radius equals 1, and it says it gets reflected from the tangent at 0, -1. So this tangent is at y equals -1 line. That is, we have this incident ray which passes through -2, -1, and the reflected ray is tangent to this circle. Now this ray of light is incident at this point -2, -1. So this point is -2, -1, basically, which is a point of incidence. Now what we'll do is we'll write equation of tangent to this circle in terms of its slope. So this is y equals mx plus minus r under root 1 plus m square, and we need the tangent which passes through -2, -1. So we'll put x as -2 and y as 1. We'll get 2m minus 1 equals plus minus under root 1 plus m square. Now this is 4m square plus 1 minus 4m, and this is 1 plus m square. Now this 1 and 1 will cancel, so we'll get this value as 3m square minus 4m equals 0. So either m is 0 or m is 4 by 3. Now slope of reflected ray is 4 by 3, and we know that if this angle is theta, this angle is also theta. So this angle is pi minus theta. So slope of incident ray is minus 4 by 3. Now once we have point and slope, we can write its equation. So it will be this y plus 1 minus 4 by 3 x plus 2. So it will be this 4x plus 3y plus 11 equals to 0. That's your option B. Now here the question is, two circles of radius R1 and R2, they touch each other externally. Then radius of circle which touches both of them externally, and also their direct common tangent is. So we have two circles which touch each other externally, and this line, it is their common tangent. Now suppose radius of this circle is R1 and radius of this other circle is R2. Now we have to find radius of this third circle which touches both of them externally and which also touches their direct common tangent. Now suppose this radius is R. Now let these points of contact be A, B and C. Now we know this result that when two circles, they touch each other externally, then length of their direct common tangent, it is given by 2 under root R1, R2. So for these two circles, length of tangent, which is AB, will be given by 2 under root R1R, BC is 2 under root R2R, and AC is tangent between these two circles, and there will be 2 under root R1, R2. Now AB plus BC is AC. So we can write 2 under root R1R plus 2 under root R2R. It is equal to 2 under root R1 R2. Now this 2 will cancel. So now we can write under root R as under root of R1 R2 upon under root R1 plus under root R2, and this radius R will be R1 R2 upon under root R1 plus under root R2 whole square. That's your option A. So this is first method of solving this question using length of direct common technique. Now another way to solve this question is using Descartes' rule of kissing circles. Now this rule says if there are 4 circles which touch each other, then curvature of fourth circle K4, which is inverse of its radius, it is given by K1 plus K2 plus K3 plus minus 2 under root K1 K2 plus K2 K3 plus K3 K1. Now this is R1 and this is R2, and these circles, they touch this given circle externally. So their curvature, they'll be positive. So we'll write K1 as 1 upon R1 and K2 as 1 upon R2. And for this straight line, the radius is infinite. So basically its curvature will be 0. So we can write this K4 as 1 upon R1 plus 1 upon R2 plus minus 2 under root R1 R2. So it will be R1 R2, and here will be this R2 plus R1 plus minus 2 R1 R2 under root. So it will be under root of R2 minus plus minus under root R1 whole square upon R1 R2. Now radius is reciprocal of curvature. So basically R4, which in this case is R, will be equal to R1 R2 upon under root R2 plus minus under root R1 whole square. Now there will be 2 such circles, and this other circle will be very big. So if we have 2 circles like this, then we have this smaller circle, and then we'll have this larger circle which is going to touch both the circles as well as this straight line. So here we are talking about radius of this smaller circle. Now for this radius of smaller circle, we'll use plus sign. So radius of this smaller circle will be R1 R2 upon under root R1 plus under root R2 whole square. So in this case, answer is this option A. Now the question is, if C, C1, C2 be circles of radius 5, 3 and 2 respectively, if C1, C2 touch externally and they touch internally with C, then radius of circle C3 which touches externally with C1, C2 and internally with C is. So here we have this bigger circle which is C, and its radius is 5, and then we have 2 smaller circles C1 and C2, and their radius are 3 and 2 respectively. Now this third circle, it touches these 2 circles C1, C2 externally and this circle C internally, and we have to find its radius, say R3. Now we can write K1 as 1 upon 3 because it touches externally, so we have taken it as positive. In the same we can take K2 positive, so it will be 1 by 2. Now curvature for this bigger circle, it will be negative, and that will be K4, and it is minus 1 by 5. Now once we have
3 curvature, we can find the fourth one using Descartes' rule of kissing circles. So we can use this formula. Now in this case, we have the value of K1, K2 and K4. We'll just put the value of K1, K2, K4 to find the value of K3. Now we simplify this square root expression. So it will be 5 minus 3 minus 2, which is 0. So this entire expression will be 0. So in that case, we'll get the value of K3 as 19 by 30. And once we have got curvature, we can write its radius. And its radius will be reciprocal of the curvature, which is 30 by 19. And that's your option A. Now here the question is, a square OABC is formed by lines xy equals 0, xy plus 1 equals x plus y, where O is origin. A circle with center C1 inside the square is drawn to touch the line pair xy equals 0, and another circle with center C2 and radius twice of C1 is drawn to touch the circle C1. Now we are given xy equals 0 and xy plus 1 equals x plus y. Now if we simplify the second one, we can factorize it. So we can factorize this as 1 minus x into 1 minus y equals 0. So from here we'll get x equal to 1 and y equals to 1. So we'll have this square whose two sides are along x-axis and y-axis, and the other two sides are along x equals 1 and y equals 1. So this is a square. Now a circle with center C1 is drawn, which touches the pair xy equals 0. So let us draw this circle. And then we have another circle C2, which touches the other two lines and whose radius is twice of that of this first circle. So we'll draw that as well. Now we have to find radius of this first circle. Now it is given that R2 is 2R1. Now since the circle C1, it touches both the axes, its center will be R1, R1, whose radius is R1. Now radius of the second circle is 2R1. So its center will be 1 minus 2R1 and 1 minus 2R1. So we can write C2 as 1 minus 2R1, 1 minus 2R1, and its radius will be 2R1. Now since these two circles, they touch each other externally, we can write C1, C2 equals R1 plus R2. Now C1, C2 is 1 minus 3R1 root 2, and that will be equal to 3R1. Now we can simplify this to find the value of R1. Which is your option C. Now here the question is, if PQR is a triangle formed by common tangents to these two circles, then which of the following is correct? So we are given two circles. Both the centers, they lie on x-axis. Center for the first one is minus 3, 0. And for the second one it is 1, 0. Its radius is 3. And for the second one, radius is 1 unit. So they'll be touching each other at origin. Now we have to find this triangle formed by their common tangents. One of the common tangent is this y-axis itself. So we are talking about this triangle P, Q, and R. Now we are given two centers C1 and C2. Now this point P, it will divide C1, C2 in the ratio 3:1 externally. So we can find this point P. So this is 3 into 1 plus 3 upon 2. So that will be 3. and this is 0. So this point P is 3, 0. Now this is origin, and what we'll do is we'll find this angle OPQ. Let it be theta. So we'll drop a perpendicular from 1, 0 to its tangent. Its radius is 1 and this distance is 2. So we can write sine theta as 1 by 2. And if sine theta is 1 by 2, that means theta is pi by 6. And if theta is pi by 6, that means angle P is 60 degrees. Now if this angle P is 60 degrees, these two sides they're equal. That means angle Q and angle R, they're also 60. So this triangle PQR will be an equilateral triangle. Now this is in circle, so its in radius will be 1 unit. Its in center is at 1, 0 and its in radius is 1 unit. And also it is an equilateral triangle. So all the center they'll be at in center. So its centroid will also be at 1, 0. So option A is correct, option B is correct, and option D is correct. Now its circumradius will be equal to C2P, and this is 2. So that means this option C is also correct. Now the question is two circles of radius A and B touching each other externally are inscribed in the area bounded by y equals under root 1 minus x square, which essentially is a semicircle and x-axis, and it says if B is 1 by 2, then 4A is equal to what? So we'll draw the semicircle whose center is at origin and radius 1. So these two coordinates, they'll be 1, 0 and minus 1, 0. Now this is 0, 1, and since B is 1 by 2, and which is radius of one circle, its diameter will be 1. So that means that circle can only be drawn with endpoints of diameter as 0, 1 and 0, 0. So that's your second circle whose radius is B. So this is how we can draw this circle. We'll join these 2 points. Let the center be C1 and its radius is 1 by 2. So this is 1 by 2 and this is 1 by 2. Now we'll draw this smaller circle whose radius is A. And suppose its center is C2. Now we'll join this perpendicular on x-axis and C1, C2. Now this is A and C1, C2 will be A plus 1 by 2. Now we'll join C2 with O and extend it. Now this entire radius is 1 unit and radius of this smaller circle is A. So this OC2 will be 1 minus A. Now from this C2 we'll drop a perpendicular on OC1. Now this distance will be simply 1 by 2 minus A. Let this point be A and the other point be B. Now in this right angle triangle C2B C1, we can write C2B square as this C1 C2, which is A plus 1 by 2 square minus 1 by 2 minus A whole square. Now we simplify this, we'll get this as 2A. Now the C2B is same as OA, which we can find from this triangle OAC2. So this OA square will be 1 minus A square minus A square. So there will be 1 minus 2A. Now both the lengths they are equal. So if we equate them, we can write 1 minus 2A equals 2A or 4A equals 1. So the value of 4A is 1. Now the question is, from a point P outside of a circle with center at O, tangent segments PA and PB are drawn if 1 upon AB square plus 1 upon PA square equals 1 upon 16, then length of chord AB is. Now here it should not be 1 upon AB square, it should actually be 1 upon AO square. So please correct this question, write it as AO. So we have this circle with center at origin. And there is this point P from which tangent segments P and PB are drawn. So this is A and this is B. Center is at origin. Now this is radius R, this is 90. We'll join this chord AB. Now suppose this angle is theta. Now AO upon AP is tan theta. Now we are given 1 upon AO square plus 1 upon PA square is 1 by 16. We can write AO square as AP square tan square theta. So we can take 1 upon AP square common. So this is 1 plus cot square theta and 1 plus cot square theta is cosec square theta. So we can write this as cosec square theta upon AP square and that will be equal to 1 by 16, or we can write AP sin theta as 4. Now in this triangle, suppose APC, we can write AC upon AP equals sin theta, or AC is AP sin theta. Now AP sin theta is 4, so value of AC is 4. Now AB is 2 times of AC, so value of AB is 8, and that is the answer to this question. Now the question is, if the line x plus y equals n, where n belongs to natural number, is chord of this circle x square plus y square equals 4, then which of the following is our arc correct? And radius equals 2 units. Now this line, it is chord of the circle. Now this line will be chord of the circle if perpendicular distance from center, it is less than its radius. So that means value of mod n should be less than 2 root 2. Since n is positive, n is less than 2 root 2. 2 root 2 is 2.8. So that means the value of n can be 1 and 2. So that means number of such chords can be 2. Now first one is sum of squares of length of chords intersected by this line. Now we'll find length of chords. So from center, we draw this perpendicular. This is n by root 2 and its radius is 2 units. So this ln, it will be under root of 4 minus n square by 2 and into 2, because we need length of this whole chord. So this ln square will be 16 minus 2n square. Now we have to find sum of squares of lengths when n is 1 and n is 2. So we will take this summation. So it will be this 16 minus 2 plus 16 minus 2 into 2 square. So that will be 32 minus 10 and that will be 22. That means this option A is correct. Now the question is, fxy equals to 0 be the equation of a circle such that f0, y has equal roots and fx, 0 has two distinct real roots. And if angle between the tangents drawn from point P to fxy equals 0 is pi by 3, then locus of P is a circle whose equation is x square plus y square minus 5x minus 4y plus c equals 0. Let Q be a point from which tangents to gxy equals to 0 are perpendicular and AB is chord of contact of Q with respect to gxy equals to 0. Then solve the following questions. So we have this circle and whose equation is fxy equals 0. And we have this point P outside of the circle from which we have drawn two tangents P and PB. Now this angle is pi by 6. If we drop a perpendicular, this is radius r, and suppose center is HK and point P is alpha beta. So we can write r upon Cp, that will be equal to sin pi by 6, 1 by 2. So Cp is 2r. Now this P is suppose alpha comma beta. So we can write alpha minus h whole square plus beta minus k whole square and will be equal to 4r square. Now we'll write locus of P. So we'll replace alpha with x and beta with y. So it will be x square plus y square minus 2hx minus 2ky plus h square plus k square minus 4r square and will be equal to 0. Now we'll compare it with the given equation, which is x square plus y square minus 5x minus 4y plus c equals 0. Now we compare it directly, we'll get 2h equals 5 and 2k equals 4. So this fxy equals to 0 will be x square plus y square minus 5x minus 4y plus lambda equals 0. Now it is given that f0 comma y has equal roots. So if you put x as 0, we'll get this as y square minus 4y plus lambda equals 0. So from there we'll get value of lambda as 4. So once we have this lambda, we can write fxy as x square plus y square minus 5x minus 4y plus 4 equals 0. And that's your option D. Now center of the circle is 5 by 2, comma 2. And its radius is 5 by 2. We have this point P, which makes an angle 60 degrees. So this angle is 30 degrees. Now this is 5 by 2. So this CP will be simply 5. So gxy equals 0 will be x minus 5 by 2 square plus y minus 2 square equals 5 square. So this is the equation of gxy equals 0. Now we have to find area of triangle QAB. And Q is point from where tangents to gxy are perpendicular. So this Q will lie on director circle of gxy. And AB is chord of contact of Q with respect to gxy equals 0. So from Q, perpendicular tangents are drawn to gxy. Now radius of gxy is 5. This angle is 45 because entire angle is 90 degrees. So this is also 5. And in this right angle triangle, we can write QR as 5 by root 2. So we'll get this QR. So this AR is 5 by root 2. That means this AB is 5 root 2. So the area of this triangle will be 1 by 2 into 5 by root 2 into 5 root 2. Now this root 2 will cancel. So it will be this 25 by 2 and that's your option A. Now this third one is length of x-axis intercept made by gxy equals 0. Now length of x-axis intercept is 2 times under root g square minus c. So this is 2 times under root and this is 5 by 2 square 25 by 4 plus 59 by 4. And that will be 2 root 21 or under root 84. And that's your option B. Now the question is, consider the relation 4l square minus 5m square plus 6l plus 1 equals 0. Then this line lx plus my equals to 1 touches a fixed circle. We have to find center and radius of this circle. So we are given this line lx plus my equals 1. Now let this circle be x square plus y square plus 2gx plus 2fy plus c equals 0. Now center is minus g minus f and radius is under root of g square plus f square minus c. Now this line, it is tangent to this circle. That means perpendicular distance from the center must be equal to its radius. So we can write minus LG minus MF plus 1 upon under root of L square plus M square, and that will be equal to its radius, which is under root of G square plus F square minus C. Now we'll square it. L square G square plus M square F square plus 1 plus 2 LMGF minus 2 LG minus 2 MF, and it will be equal to G square L square plus G square M square plus F square L square plus F square M square minus C L square minus C M square. Now here G square L square will cancel and M square F square will also cancel. So we can rewrite this as F square minus C L square plus G square minus C M square minus 2 LM GF plus 2 GL plus 2 MF minus 1 equals 0. Now what we'll do is we'll make it plus 1, because in that condition they have given it as plus 1. So we'll change the sign of each term. So here will be this plus 1. So this is minus, minus, plus. This is minus G square plus C and minus F square plus C. Now we'll compare it with the given condition, which is 4L square minus 5M square plus 6L plus 1 equals 0. And we compare this plus 1, so we get C minus F square equals 4, C minus G square equals minus 5. Now there is no term containing M, so that means F must be 0. So from here we get F as 0. C equals 4, and if we put C as 4, we'll get G as plus or minus 3. Now we compare this 6L with minus 2GL, we'll get this G as minus 3. So value of G is minus 3. So once we have G, F and C, center of the circle is minus G minus F. So here G is minus 3, F is 0 and C is 4. So equation of this circle will be x square plus y square minus 6x plus 4 equals 0. And center is at 3, 0 and its radius is root 5. And that's your option C. Now the second one is number of tangents which can be drawn from the point 2, minus 3. So we'll find S1. So there will be 4 plus 9, 13. 13 minus 12 plus 4, which is positive. So this point, it lies outside. So that means 2 tangents can be drawn. So answer to the second question is this option C. Now third one is from this point 2 tangents are drawn, P and PB. And we have to find the value of P into PB. Now P into PB is basically under root S1 square. So this is under root 5 and under root 5. So it will be simply 5, and that's your option B.
Now here the question is 5 circles with radius R1, R2, R3, R4 and R5 in increasing order be such that Ci plus 1 touches externally for all I, and if all the 5 circles touch each of the 2 straight lines L1, L2 and R1 equals 2 and R2 equals 5, then R3 is equal to what? Now we know that circles with a common tangent and which touch each other externally, their radius, they are in GP. So it's a standard result that these radiuses R1, R2, R3, R4 and R5, they'll be in geometric progression. Now here R1 is 2 and R5 is 32. Now R5 is R1 into R to the power 4. So this is 32 and this is 2 into R to the power 4. So value of R is 2. Now R3 is basically R1 into R square. So there will be simply 8 and that's your option A. Now here the question is, two circles with center at A and B touch at T. BD is tangent at D and TC is common tangent. AT has length 3 and BT has length 2. Then the length of CD is. So we have two circles with centers at A and B. So this is your circle 1 and suppose this is your circle 2. And their centers, they are at A and B. And they touch each other at this point T. Now we have a common tangent TC and BD is tangent at D. So this BD, it is tangent at D and this point is C. Now it says AT is 3, BT is 2. So this radius is 3 and this radius is 2. We have to find length of CD. Now this is 3 and this whole length will be 4 units. Now if this is theta, we can write tan theta and tan theta will be 3 by 4. Now in this triangle BTC, we can write cos theta equals BI upon BC. Now cos theta is 4 by 5, BT is 2 and this is BC. So basically your BC is 5 by 2 and if BC is 5 by 2 then CD is 4 minus 5 by 2 which is 3 by 2 and that's your option B. Now here the question is, if C1, C2 are two circles of radius A and B respectively touching both the coordinate axis and their centers in first quadrant. So here we have coordinate axis, we have this circle C1 and then we have this other circle C2 which touches this circle and also these two axes. Now basically C1 will have center at A, A and its radius is A and C2 is at B, B and its radius is B. Now we know that if they touch each other externally then C1, C2 it is equal to R1 plus R2. Now C1, C2 will be B minus A root 2 and this is equal to B plus A. Then we can write B into root 2 minus 1, it is equal to A into root 2 plus 1. So essentially B upon A will be equal to root 2 plus 1 upon root 2 minus 1, or we can write this as 3 plus 2 root 2. That means this option A it is correct. So that's your part A. Now for this part B it says C1, C2 they are orthogonal. So if they are orthogonal, in that case C1, C2 square it is equal to R1 square plus R2 square. Now C1, C2 square is B minus A square into 2 and it is equal to A square plus B square. So now we'll get this as A square plus B square minus 4AB equals 0, or we can write B upon A whole square minus 4 B upon A plus 1 equals to 0. Now B upon A will be B plus minus under root of B square minus 4AC upon 2. So there will be 2 plus minus root 3. And since b is greater than a, we have to choose plus sign. So in this case, b upon a will be 2 plus root 3. That means this option B is also correct. Now C is, if C1, C2 intersect in such a way that their common chord has maximum length, then B upon A is. Now, if common chord has maximum length, then in that case, this common chord will be diameter of this first circle. So these two circles, they'll be drawn like this. Because for these two circles, common chord cannot be greater than diameter of smaller circle. Now this is B comma B, and this is A comma A, and this is A. And this is B. So in this case, A square plus C1 C2 square will be equal to B square. Now C1 C2 square is B minus A whole square into 2, and this is B square minus A square. Now it will be 2B minus A equals B plus A, or B equals 3A. In this case, value of B upon A will be equal to 3. So for this third part, it is given that this B upon A, it is equal to 3. That means this option C is also correct. Now D is, if C2 passes through center of C1, then B upon A is this value. Now for this fourth part, we given that this C2, it passes through center of C1. Now this is A comma A, this is B comma B, and here distance between them will be equal to B. So here C1 C2, it is equal to B, and C1 C2 is B minus A root 2, and it is equal to B. So this B upon A will be root 2 upon root 2 minus 1, or this is 2 plus root 2. That means this option D is also correct. Now here the question is, if xy be a real variable satisfying this equation. So basically xy, they lie on the circle with center at minus 4 comma 5 and radius equals 16 plus 25 plus 40. Now this is 81, so it will be 9. And we are given A is maximum value of this expression, B is minimum value of this expression. Now basically this is distance between x, y and this given point A, which is minus 2 comma 3. Now if we find the CA, this CA will be 4 plus 4, which is 2 root 2. That means this point A, it lies inside the circle. Now minimum distance of this point A from the circle will be this value A, and maximum distance will be equal to B. Now its maximum distance from a point on the circle, it is this value. So this is A and this is B. So in this case, this A will be R plus CA, which is 9 plus 2 root 2, and B is R minus CA, and it is 9 minus 2 root 2. Now A plus B, it is 18. A minus B is 4 root 2, and A into B is 81 minus 8, 73. So the correct options are 18, 4 root 2 and 73. A, C and B. Now here the question is, we are given two fixed points, A minus 2 comma 0 and B 2 comma 0, such that PA minus PB, it is equal to 2. Now we know that if this is the condition, then it represents which opens towards the right. So this locus will be this branch of hyperbola where the two focus are minus 2, 0 and plus 2, 0. And we have this circle which is x square plus y square equals r square. Now using this information, we have to match column 1 with column 2. Now in A it says, if r is 2, then number of points P satisfying this hyperbola and circle is. Now if r is 2, then this circle will be drawn like this. In that case, it is going to intersect this hyperbola branch at 2 points. So number of points P satisfying both the equations is 2. That means this A, it matches with P. Now A matches with P is only one option. So answer is this option D. Now we have to find if R is equal to 1, then number of points satisfying the two equations. Now for this hyperbola, PA minus PB is 2A. So that means A is 1 and distance between focus is 4. That means 2AE, it is 4. So value of E is simply 2. Now we can find B square and there will be A square into E square minus 1. So this value, it is 3. So equation to this hyperbola is x square upon 1 minus y square upon 3 equals 0. So this point, it is at 1, 0. Now if we draw a circle with radius 1 unit, it is going to touch this hyperbola at 1, 0. So there will be only 1 point. So this B, it matches with S. Now the C is for R equals to number of common tangencies. Now if we take R as 2, then for the C part, equation of circle is x square plus y square equals 2 square, and equation of hyperbola is x square minus y square upon 3 equals to 1. Now equation of tangent to this circle will be y equals mx plus minus r under root 1 plus m square, and here for this hyperbola will be y equals mx plus minus under root a square m square minus b square. Now these two, they should be same, so we'll get 2 under root 1 plus m square, it should be equal to m square minus 3. So this is 4 plus 4m square and it is equal to m square plus 3, or m square equals minus 7 by 3, which is less than 0. So no tangent is possible. So in this case, number of common tangents will be simply 0. So the C, it matches with R. And for r square equals 1 by 2, number of common tangents is. Now if we have r square as 1 by 2, then tangent to this circle will be y equals mx plus minus 1 by root 2 under root 1 plus m square, and hyperbola will be same, y equals mx plus minus under root m square minus 3. Now if we equate them, we get 1 by root 2 under root 1 plus m square, it should be equal to under root of m square minus 3. Now this is 1 plus m square, and here will be 2m square minus 6, or m square is 7. Now in this case, we'll have two values of m, plus under root 7 and minus under root 7. So in this case, the number of common tangents will be 2. So this D, it matches with P. And that is the answer to this question. Now here the question is, if the circle C1 touches x-axis and this line y equals x tan theta in the first quadrant, and circle C2 touches y equals 10x and y-axis, and circle C1 in such a way that ratio of radius to C1 to radius of C2 is 2:1, then the value of tan theta is under root a minus b upon c. Then we have to find the value of a plus b plus c by 11. Now we have coordinate axis, and then we have this line y equals x tan theta. And this angle will be theta. Now there is this circle C1 which touches x-axis and this line, and we have this other circle C2, which touches y-axis, this line, and this circle. So this is C1 and this is C2. Now we have to find the value of tan theta by 2. And it is given that R1 is to R2 is 2. Now, if we join these, then this angle, this is theta by 2. And this is pi by 2 minus theta. So this half angle will be pi by 4 minus theta by 2. That means angle between these two dotted lines, it is pi by 4. Now we join these. This is 90 and this is 90. Now suppose this common side of two triangles, its length is x. Then in this first triangle we can write tan pi by 4 minus theta by 2 will be equal to R2 upon x. And in the second triangle we can write tan theta by 2 will be equal to R1 upon x. Now what we'll do is we'll divide first with second. So we can write tan pi by 4 minus theta by 2 upon tan theta by 2 will be equal to R2 upon R1. And this value is 1 by 2. Now this is 1 minus tan theta by 2 upon tan theta by 2 upon 1 plus tan theta by 2, and it is equal to 1 by 2. Now we have to find the value of tan theta by 2. So we'll take tan theta by 2 as x. So it will be this x square plus x, and it will be equal to 2 minus 2x, where x is tan theta by 2. Now this equation is x square plus 3x minus 2 equals 0, or the value of x will be minus 3 plus minus under root 9 plus 8 whole divided by 2. That is, value of x is minus 3 plus minus under root 17 by 2. Now theta by 2 is an acute angle, so we'll choose positive value. So value of x here will be minus 3 plus under root 17 by 2. So in this case, value of tan theta by 2 is minus 3 plus under root 17 by 2. Now if we compare it, we'll get a as 17, b as 3 and c as 2. Now a plus b plus c by 11 will be 22 by 11, which is simply 2. So answer to this question is 2. Now here the question is, if the circles intersect in two distinct points P and Q, then this line passing through P and Q is. Now we know that if two circles, they intersect each other, then line passing through their point of intersection is their common chord, which is actually their radical axis. So equation of this line is radical axis, and it is basically S1 minus S2 equals 0. So if we subtract equation 2 from equation 1, we'll get this as 5ax plus c minus dy plus a plus 1 equals 0. And they have given that if this equation is 5x plus by minus a equals to 0, then how many values of a are possible? Now if these two equations, they represent the same line, then a1 upon a2 must be equal to b1 upon b2, and it should be equal to c1 upon c2. So we'll get 5a upon 5 equals c minus d upon b equals a plus 1 upon minus a. Now this 5 and 5 will cancel. So if we take first and third, we get a square plus a plus 1 equals to 0. Now in this case, d is less than 0. So there is no solution to this equation. So answer to this question is this option B, no value of A. Now here the question is, if R and R dash are radius of circles S equals 0 and S dash equals 0. So we have two circles, S equal to 0 and S dash equals 0, and radius of this circle is R and radius of this circle is R dash. And we are given two circles which are S upon R plus minus S dash upon R dash equals 0. Now we have to find angle between these two circles at their point of intersection. Now basically this is a standard result. These two circles, they'll intersect orthogonally. That means angle between the two circles is pi by 2. So it will be this option 3. Now one way of proving it can be, we can consider two circles which are S plus lambda S dash equals 0 and S minus lambda S dash equals 0, where S is x square plus y square plus 2g1x plus 2f1y plus c1 equals 0, and S dash is x square plus y square plus 2g2x plus 2f2y plus c2 equals 0. Now equation of these two circles will be given by x square 1 plus minus lambda plus y square 1 plus minus lambda plus 2 g1 plus minus lambda g2x plus 2 f1 plus minus lambda f2y plus c1 plus minus lambda c2 equals to 0, or we can write this equation as x square plus y square plus 2 g1 plus minus lambda g2 upon 1 plus minus lambda into x plus 2 f1 plus minus lambda f2 upon 1 plus minus lambda plus c1 plus minus lambda c2 upon 1 plus minus lambda equals 0. Now we'll find the value of lambda so that these two circles, they intersect orthogonally. Now they'll intersect orthogonally if 2 g1 g2 plus f1 f2, it is equal to c1 plus c2. So we can write 2 times g1 plus lambda g2 upon 1 plus lambda into g1 minus lambda g2 upon 1 minus lambda plus f1 plus lambda f2 upon 1 plus lambda into f1 minus lambda f2 upon 1 minus lambda, it is equal to c1 plus c2, and that will be c1 minus lambda c2 upon 1 minus lambda plus c1 plus lambda c2 upon 1 plus lambda. Now we can write this as 2 g1 square minus lambda square g2 square plus f1 square minus lambda square f2 square. Now this 1 plus lambda 1 minus lambda will cancel, and here it will be c1 1 plus lambda plus c1 1 minus lambda. So there will be 2c1, and here will be minus 2 lambda square c2. Now what we'll do is we'll take terms of lambda together and other terms together, and also this 2 will cancel. So we can write g1 square plus f1 square minus c1, it is equal to lambda square g2 square plus f2 square minus c2. Now this is basically r1 square, and this is lambda square, and this is r2 square. So lambda is plus minus r1 upon r2. So these two circles, they'll be orthogonal if S plus minus r1 upon r2 S dash equals to 0, or we can rearrange this as S upon R1 plus minus S dash upon R2 equals to 0 will represent two circles that will intersect orthogonally. So their angle of intersection will be pi by 2. Now here the question is, tangents P and PB are drawn to this circle from the point P on the curve y equals sin x. So we have our coordinate axis, and this is the circle with center at 4,5 and radius equals to, and this other curve is your sine curve. Now it says from a point P on this curve, tangents P and PB are drawn. So we have drawn two tangents from any point on this sinusoidal curve to this circle where points of contact are A and B. Now it says this function y equals fx, it represents locus of center of circumcenter of triangle PAB. So we will find locus of circumcenter of this triangle PAB. Now we know that circumcenter of this triangle PAB is going to pass through center of this given circle, and this PC, it will be diameter for that circle. So suppose this point is M and its coordinate is alpha beta. We will find locus of M. Now we'll assume let P be h comma k. So basically k will be equal to sin h. Now this M, it is midpoint of PC. So this alpha will be h plus 4 by 2 and beta will be k plus 5 by 2. Now what we'll do is we'll put the value of h and k in this equation. So this k will be 2 beta minus 5 and it will be equal to sine 2 alpha minus 4. So this required locus of circumcenter will be this y equals 1 by 2 sine 2x minus 4 plus 5 by 2. So that's your curve y equals fx. Now this first question is find the range of fx. Now we know that minimum value of sin theta is minus 1. So minimum value of y will be minus 1 by 2 plus 5 by 2, which is 2, and maximum value of y will be 1. So it will be this 1 by 2 plus 5 by 2, 3. So range of this function will be from 2 to 3, and that's your option D. Now this second question is find the period of this function y equals fx. Now it is a sine function, so its period will be given by 2 pi divided by coefficient of x, which is 2. So this function is periodic with the period pi, and that's your option C. And then this third one is which of the following is true. Now this A is fx equals to 4 has real roots. Now we know that range of fx is 2 to 3. So this fx, it cannot take the value 4. So this option A is obviously incorrect. Now B is fx equal to 1 has real root. Now again 1, it doesn't lie in the range. So this B is also incorrect. Now C is range of f inverse x. Now if we find its inverse function will be 1 by 2 sine inverse 2x minus 5 plus 2. Now we have sine inverse function here. Minimum value of sine inverse is minus pi by 2. So its minimum value is 2 minus pi by 4, and its maximum value is when sine inverse x is pi by 2. So it will be this 2 plus pi by 4. So range of its inverse function is from 2 minus pi by 4 to 2 plus pi by 4. That means this option C is correct. So the correct option is this option C. Now here the question is, let orthocenter and centroid of triangle be A and B, and if C is circumcircle of this triangle, Then radius of circle having line segment AC as diameter is. Now we know that O, G and H, they are collinear, and G divides OH in the ratio 1:2, where H is orthocenter, G is centroid, and O is circumcenter. Now in this case, orthocenter is -3,5. So this is -3,5. Centroid is at B, which is 3,3, and C is circumcircle. Now if we find this AB is 6 square plus 2 square, and that will be under root 40, which is 2 root 10. Now AB upon AC is 2:3. So this AC will be 3/2 into AB. So this is 3/2 and AB is 2 root 10. So value of AC is 3 root 10. Now this AC is diameter, so its radius will be AC/2, which is 3/2 into under root 10 or 3 into under root 5/2, and that's your option C. Now here the question is center of the circle which passes through the point 0, 1 and touching this curve y equals x square as 2, 4. So we have this parabola y equals x square, and here we have a point on this parabola which is 2, 4. Now it says center of the circle passing through this point and touching this parabola at this point. So we'll have a circle which will touch this parabola at this point 2, 4. Now this point, it lies on this parabola. We can find equation of tangent to this parabola, this point P, and this equation it is given by t equals 0. It will be 5 plus 4/2 and it is equal to 2x. So equation of this tangent is 4x minus y minus 4 equals 0. Now what we'll do is we'll find equation of family of circles which touches this straight line at this point 2, 4. So equation of family of circles will be given by x minus 2 square plus y minus 4 square plus lambda 4x minus y minus 4 equals to 0. Now from this family, we'll need a circle which passes through this point 0, 1. So we'll put the value of x as 0 and y as 1. So it'll be this 4 plus 9 plus lambda minus 5. So value of lambda is 13/5. So equation of this circle will be x square plus y square minus 4x minus 8y plus 20 plus 52/5x minus 13/5y minus 52/5 equals 0. Now we can write this equation as x square plus y square, and it is minus 20 plus 52. So plus 32/5x, and here it is minus 8 minus 13, 40 and 13, 53. So there will be minus 53/5y, and this is 100 minus 52, which is 48/5 equals 0. Now center of this circle will be at minus 16 by 5 and 53 by 10. Now here the question is abscissa of 2 points A and B are roots of this equation. So suppose we have 2 points A and B, and A is x1 y1 and B is x2 y2. Now it says abscissas of 2 points. That means x1 and x2, they are roots of this equation. X square plus 2ax minus b square equals 0, which we can also write as x minus x1 into x minus x2, and their ordinates are roots of this equation. So y1 and y2, they are roots of the equation y square plus 2py minus q square equals 0, which is y minus y1 into y minus y2. Now it says find the equation and radius of circle with AB as diameter. Now equation of circle with AB as diameter is given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals 0. Now we already have these two. This is x square plus 2ax minus b square, and this is y square plus 2py minus q square equals 0. So equation of this circle will be x square plus y square plus 2ax plus 2py minus b square minus q square equals 0. Now center of this circle is at minus a minus b, and its radius will be under root of a square plus b square plus b square plus q square, which is what we need to find in this question. Now here the question is, if a variable line 3x plus 4y minus lambda equals to 0 is such that two circles, this first circle x square plus y square minus 2x minus 2y plus 1 equals to 0 with center at 1, 1 and radius equals 1, and this second circle with center at 9, 1 and radius equals 2 are on its opposite sides. Now first condition is these two centers, they lie on opposite side of the line. So that means if we want to put this point 3 plus 4 minus lambda and this other point 27 plus 4 minus lambda, their product, it should be negative. That means lambda minus 7 into lambda minus 31, it should be less than 0, or value of lambda should lie between 7 and 31. So that's the condition that centers lie on other side of the line. So that's our first condition. Now we have the second condition that these circles, they should not intersect this line. So if we take this first circle, then perpendicular distance from center must be greater than its radius. So perpendicular distance from center, this is 3 plus 4 minus lambda upon 5, it should be greater than 1. And in the same way for the second one, we'll get perpendicular distance from center, so there will be 27 plus 4 minus lambda upon 5, it should be greater than 2. Now we'll simplify these two conditions. This is mod of lambda minus 7 greater than 5, and here will be lambda minus 31 is greater than 10. Now this lambda is greater than 7 and it is less than 31. So here we'll get lambda minus 7 is greater than 5, or lambda is greater than 12. And here these circles, they may also touch this line. So we're going to include this equality sign at both the places. So lambda should be greater than or equal to 12, and here lambda minus 31 will be negative. So it will be minus lambda plus 31, it is greater than or equal to 10, or lambda is less than or equal to 21. So this lambda, it should lie between 12 and 21. That means answer to this question is this option C. Now the question is, let ABCD be a square of side length 2 unit
C2 is the circle through vertices ABCD, and C1 is the circle touching all the sides of square ABCD. And L is any line through A. Then this first question is, P is the point of C1 and Q is the point of C2. Then PA square plus PB square plus PC square plus PD square upon QA square plus QB square plus QC square upon QD square is equal to what? So basically, this ratio, it is fixed. It doesn't depend on which point we are taking on C1 and which point we are taking on C2. So what we'll do is, without loss of generality, we'll assume this square with two sides on coordinate axis. So it is 0, 0, 2, 0, 0, 2, and 2, comma 2. Now suppose this point is A, this is B, this is C, and this is D. Now center of this square, it is at 1, comma 1. This point is 1, comma 1. Then we have this circle which touches all the four sides, and that's your circle C1. Now for C1, radius is 1 unit. So this C1 is x minus 1 square plus y minus 1 square equals 1. And C2 is a circle which passes through all the four vertices. Now for C2, radius is root 2. So equation of C2 is x minus 1 square plus y minus 1 square, and it is equal to 2. Now it says we have taken a point P on C1. So we have this circle C1 and we have to take a point P on this. We can take this point P as 1 plus cos theta and 1 plus sin theta. Now first we'll simplify this PA square plus PB square plus PC square plus PD square, and it should come independent of theta. Now PA square is 1 plus cos theta square plus 1 plus sin theta square. Now PB square is 1 minus cos theta square plus 1 plus sin theta square. PC square is 1 minus cos theta square plus 1 minus sin theta square, and PD square is 1 plus cos theta square plus 1 minus sin theta whole square. Now basically it is 2 times 1 plus cos theta square and 1 minus cos theta square plus 1 plus sin theta square and 1 minus sin theta square. Now here this is 2. Now here we'll get this as 2 plus 2 cos square theta. 2 cos theta will cancel. In the same way we'll get 2 plus 2 sin square theta. Now cos square theta plus sin square theta, it is 1. So it will be 6. 6 into 2 is 12. So value of PA square plus PB square plus PC square plus PD square, it is 12. And because it is an objective question, the simplest way to do it is, we know that this value, it should come out independent of theta. So it's better to put any known point. So we can take this point, and this point is 1, 0. So if we take this P as 1, 0, then this sum of squares will again come out to be 12. Now this PA square is 1, PB square is 1, and now PC square is 5 and PD square is 5. So again this value, it comes out to be 12. So you could have got the answer just by assuming a point rather than solving it in a more general way. But however, here we have to solve it generally. Now let this point Q be 1 plus root 2 cos theta and 1 plus root 2 sin theta. Now in this case, everything will be same, except with cos theta and sin theta, we'll always have this root 2. So when we will find this
QA square plus QB square plus QC square plus QD square, it will be this 2 and then 1 plus root 2 cos theta square and then 1 minus root 2 cos theta square, and here will be 1 plus root 2 sin theta square and 1 minus root 2 sin theta square. Now this is 2 and here will be this 2 plus 4 cos square theta, and here will be this 2 plus 4 sin square theta. Now this is 4 plus 4, 8. 8 into 2 is 16. Now we have to find their ratio. So this ratio will be 12 by 16, which is 3 by 4 or 0.75, and that's your option A. And for Q also we could have taken a simple point. So we could have taken this origin. Now this distance is 0. Here this distance is 2 square. This distance again is 2 square. And here this distance is 4 plus 4. So it will be 16. So we could have solved this question by assuming general points, as we know this value is independent of the points that we are going to choose. Now the second question is, a circle touches the line L and C1 externally such that both the circles are on the same side of the line. Then locus of center of circle is. So for the second part, what we're given is, we have a fixed circle and we have fixed line L equals 0, and we have the circle which touches this circle and this straight line. Now we will find locus of center of this circle. Now suppose this point is P and it is alpha beta. Now this is your fixed circle, and suppose radius of this fixed circle is R, and this is C1, and this radius is R1, and this is this radius R. Now we know that this C1P, it will be R1 plus R, and this PM, it will be simply R. Now what we'll do is, if we take a fixed line which is parallel to L and which is at a distance of R plus R1, and we call this line as LH equals to 0, then in that case this C1P will be equal to this PM dash, that is distance of this point from a fixed point and a fixed line is same. So if the distance from a fixed point and fixed line is same, then this point, it lies on parabola. So locus of this circle will be a parabola in this case. Now this third part, it says a line M through A is drawn parallel to BD. So we have a line through A which we have drawn parallel to BD. So that's your line M. Point S moves such that its distance from line BD and vertex A are equal. So in this case, distance from fixed point and fixed line, it is same. So this locus of S will be a parabola. So this S will be a parabola whose focus is at A and directrix is at 1, 1. So we'll have this parabola, and its vertex will be at 1 by 2, 1 by 2. So vertex for this parabola will be 1 by 2, 1 by 2. That's it. If the locus of S cuts M at T2 and T3, so this is T2, this is T3, and AC at T1. So you will find area of this triangle T1, T2, T3. Now basically T2, T3, it is latest rectum. So T2, T3, it is equal to 4a, and this T1a, it is distance from vertex to the focus, and it is equal to a, which is under root of 1 by 4 plus 1 by 4, which is 1 by root 2. Now once we have these values, we can find area of this triangle. So area of this triangle will be this 1 by 2 and then 4a into a, so it will be this 2a square. Now a square is 1 by 2, so area of this triangle is 1 square unit, and that's your option C. So answer to this question is A, C and C. Now this is a very simple and conceptual question that says two intersecting circles. So if we have two intersecting circles, they'll have a common normal which will pass through their centers, and they'll also have their common tangent. So this A, it matches with P and Q. B is two mutually external circles. Now if we have two mutually external circles also, then also we can draw a line passing through their centers, which is going to be their common normal. So they'll have a common normal and they'll again have 4 common tangents. So this B, it also matches with P and Q. Now see two circles, one strictly inside the other. So if we have two circles where one of the circle lies completely inside the other, then in that case we can always form a line joining the two centers. So they'll have a common normal, but they won't have any common tangent. So this C, they'll have a common normal Q, but they do not have a common tangent. So this C, it matches with QR. And D is two branches of a hyperbola. Now if we take two branches of a hyperbola, this x-axis or their axis is their common normal at vertices. So they'll have a common normal. So this D, it'll have Q, but then these two branches, they can never have a common tangent. The best they have is this asymptote, which appears to meet them at, so they do not have a common tangent. So it also matches with QR. Now here the question is, tangent and normal at this point to this circle and x-axis form a triangle. The area of this triangle in square units is. Now we have this circle with center at origin and radius equals to, and we have this point which is root 3, 1. Now normal at this point, it will pass through origin, and this radius is 2, and this angle, it is 30 degrees, and this is your tangent. We will find area of this triangle. Now we know that if this is x, then x cos 30 is 2 and cos 30 is root 3 by 2. So this x is 4 by root 3. Now area of this triangle is half 2 into x into sine 30. So this is 1 by 2 into 2, and x is 4 by root 3 and sine 30 is 1 by 2. So this value will be simply 2 by root 3. So area of this triangle is 2 by root 3 square units, and that's your option C. Now here the question is, we are given a circle x square plus y square equals 4, center at origin and radius equals 2, and we have this other circle with center at 3, 0 and radius equals 1. So we have these two circles. Now it says a tangent PT is drawn to this circle at this point P. Now this point P, it lies on the circle. Then equation of tangent at this point P, it is given by t equals 0, and that will be root 3x plus y equals 4. Now it says a straight line perpendicular to PT is tangent to this other circle. Now slope of this line is minus root 3, then the slope of line which is perpendicular to this line will be 1 by root 3. So we have to find equation of tangent to this other circle whose slope is 1 by root 3. Now we know that equation of tangent is given by y equals m x minus 3 plus minus r under root 1 plus m square. So it will be this y 1 by root 3 x minus 3 plus minus, and this is 1 plus 1 by 3. So we'll get this as root 3y minus x plus 3, and it will be equal to plus or minus 2. Now if we take this plus sign, equation of this line will be x minus root 3y minus 1 equals 0, and if we take minus sign, then it will be x minus root 3y minus 5 equals 0. So a possible equation for this line is this option A. Now this next one is a common tangent to these two circles. Now one of the common tangent is at their point of contact, and this is simply x equal to 2, which is not given. So here we have to find equation of other common tangents. Now equation of tangent to this first circle is y equals mx plus minus r under root 1 plus m square, and for the second circle it is y equals m x minus 3 plus minus 1 under root 1 plus m square. Now both the equations, they should represent the same line. So here we get plus minus 2 under root 1 plus m square will be equal to minus 3m plus minus under root 1 plus m square. Now here we'll have two scenarios. Scenario 1, if these two, they have same sign, then we'll get under root 1 plus m square equals minus 3m. So we'll get 1 plus m square equals 9m square. In that case, value of m is plus minus 1 upon 2 root 2. So in this case, equation of tangent will be y equals plus minus 1 upon 2 root 2x, and here will be this minus plus, because when slope is positive, intercept is negative, and when slope is negative, intercept is positive. 2 under root 1 plus m square. So it will be 2 under root 1 plus 1 by 8. So we'll get this as 2 root 2y equals plus minus x minus plus 6. So if we take minus here and plus here, we get x plus 2 root 2y equals 6. That means it is this option D. And if we consider this second case, when they are of opposite sign, then we get 3 under root 1 plus m square equals minus 3m. Now in this case, we won't get any tangent. So answer to this question is option A and D. Now here the question is, two circles with equal radius are intersecting at points 0, 1 and 0, minus 1. The tangents at the point 0, 1 to one of the circles passes through center of the other circle. Then distance between centers of these circles is. Now we have two intersecting circles, and these two circles, they have equal radius and they intersect at 0, 1 and 0, minus 1. Now it says tangent at 0, 1 pass through center of this other circle. So tangent at this point, it passes through center of this other circle. If we join it to this other center, C2, and this is C1. Now this is 90. This is R, and this is R. Then this angle, it is 45. Now if we draw this line, this angle is also 45. Now this length, it is 1. So this length is 1, and this length will also be 1. So distance between center will be simply 2, and that's your option D. Now here the question is, three circles of radius A, B and C, where A is less than B is less than C, touch each other externally and they have x-axis as their common tangent. So here we have three mutually tangential circles. And radius of this circle is A, radius of this circle is B, and radius of this larger circle is C. And suppose their points of contact are A, B and C. Now we know that length of direct common tangent between two external touching circles is given by 2 times under root R1, R2. So in this case, this AC, it is given as 2 under root AC. AB is given as 2 under root AB, and BC is given as 2 under root BC. Now we know that BC is AC plus AB. So we can write 2 times under root BC will be equal to 2 times under root AC plus 2 times under root AB. Now this 2 will cancel. Now we'll divide everything with under root ABC. So we'll get 1 upon under root A will be equal to 1 upon under root B plus 1 upon under root C, and that's your option B. Now here the question is, find the equation of circle which passes through this point and whose center is the limit point of intersection of these two lines. So in this question we are given two lines which are 3x plus 5y equals 1, and this is 2 plus cx plus 5c square y, and it is equal to 1. Now what we'll do is we'll multiply this first equation with c square, and then we'll subtract second from first. So we'll get 3c square minus c minus 2x, and it will be equal to c square minus 1. So this x will be c square minus 1 upon 3c square minus c minus 2. Now we have to find limit point of this intersection when c tends to 1. So as c tends to 1, we have to find this limit c tends to 1, and we can write this as c plus 1, c minus 1, and this is 3c square minus 3c plus 2c minus 2, or we can write this as limit c tends to 1, c plus 1, c minus 1, and this is 3c plus 2 and c minus 1. Now c minus 1 will cancel. So if we put c as 1, we get this as 2 by 5. So x coordinate of the point of intersection is 2 by 5, and if we put x here, we'll get 5y equals 1 minus 6 by 5, which is minus 1 by 5. So this y is minus 1 by 25. So center of the circle will be at 2 by 5 and minus 1 by 25. We can find its radius also. We are given a point on this circle, so it will be this under root of 2 minus 2 by 5 square plus 1 by 25 square. Now this is 10 minus 2, 8. So it will be 64 by 25 plus 1 upon 625. So this value will be under root of 1601 upon 625. Now once we have center and radius, we can write equation of this circle. So equation of this circle will be x minus 2 by 5 square plus y plus 1 by 25 square, and that will be equal to 1601 upon 625. Now here the question is, locus of midpoints of chord of contact of tangents drawn from the points lying on straight line to this circle is. Now we have this circle whose equation is x square plus y square equals to 9, and we have found locus of midpoint of chords. So this is this point M, say alpha comma beta, from a point on this line, say P, and let this point be h comma k, and this line is 4x minus 5y equals 20. Now once we have midpoint of a chord, we can write its equation, and its equation is given by t equals s1.
So this equation will be alpha x plus beta y minus 9, and it will be equal to alpha square plus beta square minus 9. This 9 and 9 will cancel. So we'll get this equation as alpha x plus beta y equals alpha square plus beta square. Now from this point, we have drawn two tangents. Then we know that equation of chord of contact is given by t equals to 0. So for this point, we have to find t equals 0. Now t equals 0 is hx plus ky equals 9. Now both these equations, alpha x plus beta y upon alpha square plus beta square, they represent the same line. That means h upon alpha equals k upon beta, and will be equal to 9 upon alpha square plus beta square. So from here we can write h as 9 alpha upon alpha square plus beta square and k as 9 beta upon alpha square plus beta square. Now hk, they'll satisfy this equation. So we get 4h minus 5k equals 20. So this equation will be 4 into 9 alpha upon alpha square plus beta square minus 5 9 beta upon alpha square plus beta square, it is equal to 20. So we'll get this equation as 20 alpha square plus beta square minus 36 alpha plus 45 beta equals 0. In the end, we'll replace alpha with x and beta with y. So this required locus, it will be 20 x square plus y square minus 36x plus 45y equals 0, and that's your option A. Now here the question is, find the equation of tangents drawn from the origin to this circle, and center of the circle is at minus r minus h, and its radius is r. So this circle, it touches y-axis. So this is minus r minus h, and this is r. Now if we put origin in this equation, we get s1 as h square, which is greater than 0. That means two tangents can be drawn from origin to this circle. Now one of the tangent is clearly y-axis, and equation of y-axis is x equal to 0. So one of the option is this option A, and then we have this other tangent passing through origin. Now we can write this equation as x plus r square plus y plus h square, and that will be equal to r square. Then equation of tangent is given by y plus h equals m x plus r plus minus r under root 1 plus m square. Now we need that tangent which passes through origin. So we'll put x as 0 and y as 0. So we get h minus m r, it is equal to plus minus r under root 1 plus m square. So we square it, we get h square plus m square r square minus 2 h r m, and it is equal to r square plus r square m square. Now this r square m square will cancel. So here we get this m as h square minus r square upon 2 hr. Now equation of this line is simply y equals mx as it passes through this origin. So equation of this line will be y equals h square minus r square upon 2 hrx, or this equation will be h square minus r square x minus 2 hry equals 0, and that's your option C. So the correct options are A and C. Now in this question, we are given two lines, and we are given this circle whose center is at 3, minus 5, and its radius, it will be 2 units. Now L1 and L2 are basically parallel lines, and distance between these two parallel lines, it is given as 6 upon 4 plus 9, which is 6 by under root 13. Now we'll begin with the statement 2. Now 6 by root 13 is nearly 1.6.
6, 6 something. Now suppose this is L1 and this is L2. Now it says if L1 is diameter of circle C, then L2 is not chord of a circle. Now if L1 is diameter, and we know that radius of the circle is 2 units, whereas distance between lines is only 1.66. That means this L2 will always be a chord of the circle. So that means this statement 2 is incorrect. Now statement 1 is if line L1 is a chord of circle, then L2 is not always diameter of circle C. Now we can draw a circle with L2 as diameter, and for which this L1 will be a chord, and there can be other circles where L2 is not a diameter, where L1 still be a chord of this circle. So that means this statement 1, it is correct. So answer to this question is statement 1 is correct and statement 2 is incorrect, and that's your option C. Now here the question is two parallel chords of a circle of radius 2 are at a distance root 3 plus 1 unit apart. If the chords subtend at the center angle pi by k and 2 pi by k, then the value of greatest linear function of k is. So for this question we have a circle whose radius is 2 units, and then we have two chords which are at a distance of root 3 plus 1 units. Now we are given that these chords, they subtend angles pi by k and 2 pi by k at the center. Now this radius, it is 2. Now if we draw a perpendicular, suppose this is AB and this is O, then this angle, it is pi by k. So this AO is 2 cos pi by k. In the same way, this angle is pi by 2k and this is 2. So this BO is 2 cos pi by 2k. Now suppose pi by 2k is some angle theta. So we can write AO plus BO. So it will be this 2 cos 2 theta plus 2 cos theta. It is equal to root 3 plus 1. Now cos 2 theta is 2 cos square theta minus 1. So there will be 4 cos square theta plus 2 cos theta. And then it will be this minus 2 minus 1. So there will be minus 3 minus root 3 equals 0. Now this is basically a quadratic equation in 2 cos theta. So it will be this 2 cos theta square plus 2 cos theta minus 3 plus under root 3 equals 0. Now we can write 2 cos theta as minus b plus minus b square minus 4 ac whole divided by 2. Now this is minus 1 plus minus under root 1 plus 12 plus 4 root 3 upon 2, and this basically is a perfect square. So we can write 2 cos theta as minus 1 plus minus, and here it will be 1 plus 2 root 3 whole square upon 2. Now here pi upon 2k, it is an acute angle, so we are going to take only positive value. So it will be this minus 1 plus 1 plus 2 root 3 upon 2. Now this minus 1 plus 1 will cancel, this 2 will also cancel. So we get cos theta as root 3 by 2. That means this theta is pi by 6. Now we have taken theta as pi upon 2k. So it is pi by 2k. That means value of k is simply 3. So greatest linear function of value of k is 3. And that is the answer to this question. Now here the question is, in a triangle ABC, this coordinate A is at 1, 10. So this A, it is at 1, 10, and we have to find coordinate of midpoint of side opposite to A. So we have to find coordinate of this point D. So this is B and C. Now we're given that circumcenter and orthocenter are at these points. So we know that O, G and H, they are collinear. Now circumcenter is -1 by 3, 2 by 3, and orthocenter is at 11 by 3 and 4 by 3. And this G, it divides OH in the ratio 1:2. Now coordinate of this point G will be 11 by 3 minus 2 by 3 upon 3, and it will be 4 by 3 plus 4 by 3 upon 3. Now this is 1 comma 8 by 9. So coordinate of centroid, it is 1 comma 8 by 9. Now since x coordinate is same, that means this line, it is parallel to y-axis. So x coordinate for this point D will be 1. Now this G, it divides AD in the ratio 2:1. So this G, it divides AD, and suppose this is 1 comma K in the ratio 2:1, and here it is 1 comma 8 by 9. So we have to find its y coordinate. So we get 2k plus 10 by 3 will be equal to 8 by 9. Now this is 8 by 3. 8 by 3 minus 10 is minus 22 by 3. So value of k is minus 11 by 3. So coordinate of this point D is 1 comma minus 11 by 3, and that's your option 1. Now the question is, in a triangle ABC, equation of side BC is x minus y equals 0 and circumcenter and orthocenter are given. Then find the equation of circumcenter of this triangle. So in this question we are given a triangle, and suppose it is inscribed in this circle, and we have this triangle ABC. Now equation of this line BC is x minus y equals to 0, and its circumcenter, it is at 2 comma 3, and its orthocenter, it is at 5 comma 8. Now we need to find equation of circumcircle. Now for circumcircle, we are given center, we just have to find its radius. Now we have this one result, which is reflection of orthocenter about any line will lie on its circumcircle. So reflection of this point H about this BC will be this point H dash, and will lie on circumcircle. Now since this is y is equal to x line, we can do the reflection directly. So it is going to interchange x and y. So this coordinate H dash will be 8 comma 5. Now once we have point on this circumcircle, we can find this radius. This radius will be simply under root of 8 minus 2, 6. 6 square is 36 plus 5 minus 3 is 2. 2 square is 4. And that will be under root 40. Now once we have center and radius, we can write this equation. So this equation will be x minus 2 square plus y minus 3 square equals 40. So this equation will be x square plus y square minus 4x minus 6y. Now 13, 27. So it will be minus 27 equals 0, and that's your option B. Now here the question is, 8 spheres of radius 1 unit kept on a table with their centers at the vertices of regular octagon and each sphere touching its 2 neighbors. If the sphere is placed in the center on the table touching all the 8 spheres, then its radius is. Now what we'll do is, we'll view the situation from the top view as well as from the front view. Now this is the top view of this question, where we can see the centers of all the circles, their corresponding positions on this octagon. And as you can see, they're intersecting circles. Actually, they're not intersecting circles, but touching spheres. Now, if we look at their front view, then on the table, at the center, we'll have this sphere whose radius is r, and then there'll be two smaller spheres touching it. And that is the reason when you look from the top, you won't see circles touching each other. Now this radius is 1 and this radius is r. And this is distance between the centers d. Now this is 1 and this is r, and this length is r minus 1. So in this triangle, say C1, C2 and A, this is 90, then we can write C1, C2 square will be equal to AC1 square plus AC2 square. Now C1, C2 is 1 plus r, so it will be this r plus 1 square. Now AC1 square, it is distance between the centers d square plus AC2 square, and AC2 square is r minus 1 square. So from here we get d square as 4r, and that's our first equation. Now if we look at this distance d from the top view, then this distance is distance between the centers. So it is this distance d, and now this length, it is 1 and 1, 2 units, and this angle is 2 pi by 8, which is pi by 4. Now we can find d using cosine rule. We can write cos pi by 4 will be equal to d square plus d square minus 2 square upon 2d square. So it will be this 1 by root 2 d square minus 2 upon d square. Now we can simplify this as d square, it is root 2 d square minus 2 root 2, or basically d square is 2 root 2 upon root 2 minus 1. Now if we rationalize this, it will be this 2 root 2 root 2 plus 1. Now d square is equal to 4r. So if we equate d square with 4r, we get 4r equals 2 root 2 root 2 plus 1. Now 2 root 2 and 4 will cancel, so it will be this root 2 here, then this r will be 1 plus 1 by root 2, and that's your option D. Now the question is, inside a semicircle of radius 1 unit, two circles of radius r1 and r2 are drawn, each touching the circumference and diameter of the semicircle and also touches each other externally. Then this box maximum r1 plus r2 is where this box x represents integral value nearest to x. So it is not greatest value function of x. Now here we have the semicircle. And then we have two circles touching each other, and also this semicircle. Let this point of contact be A and this be B, and if we draw their common tangent, let this be M. Now basically these three lengths, they'll be equal. Now suppose this is C. Now suppose AM equals MB equals MC, and let it be A. So let this distance be A. Now we know that AB is length of direct common tangent between the two circles. Now radius of this circle is say R1 and radius of this other circle is R2. Then we know that AB is equal to 2 times under root R1 R2. So basically these lengths AM, BM and CM, they are under root R1 R2. Now suppose this angle is theta. Then if from the center we draw perpendiculars, then this is R1 and this half angle is theta by 2. So we can write tan theta by 2 as r1 upon a. So this r1, it will be a tan theta by 2. And in the same way, for this second circle, we know that this angle is pi minus theta. So this half angle is pi by 2 minus theta by 2. So it will be this a cot theta by 2. So we've got r1 and r2 in terms of a and theta. Now suppose center of this semicircle is at O. Then if we join these two and these two, this length is 1, then this length C1O, it will be 1 minus R1. And the same way, this C2O, it will be 1 minus R2. Now this AC1 is R1 and BC2 is R2. Then from here we can write this AO square, it will be 1 minus R1 square minus R1 square. So it will be 1 minus 2R1, and the same way BO square is 1 minus 2R2. Now we know that AO plus OB, it is AB and AB is 2A. So from here we can write under root of 1 minus 2R1 plus under root of 1 minus 2R2, it is equal to 2A, and R1 is a tan theta by 2. So it will be this 1 minus 2 a tan theta by 2 plus under root of 1 minus 2 a cot theta by 2, and it is equal to 2a. Now what we'll do is, we'll take this cot expression on the right hand side, and we can write under root of 1 minus 2a tan theta by 2 will be equal to 2a minus under root of 1 minus 2a cot theta by 2, and we square it, we'll get 1 minus 2a tan theta by 2 will be 4a square plus 1 minus 2a cot theta by 2 minus 4a under root of 1 minus 2a cot theta by 2. Now here this 1 and 1 will cancel. We'll cancel this 2a also. So we can write this as cot theta by 2 minus tan theta by 2 minus 2a will be equal to minus 2 under root of 1 minus 2a cot theta by 2. Now we'll square it again. We can write cot square theta by 2 plus tan square theta by 2 plus 4a square minus 2 cot theta into tan theta is 1 minus 4a cot theta by 2 and plus 4a tan theta by 2. It is 4 minus 8a cot theta by 2. Now we can write this as cot square theta by 2 plus tan square theta by 2, and here it is plus 4a, and here we'll take cot theta by 2 plus tan theta by 2, and then we have this minus 6 plus 4a square equals 0. Now what we'll do is, we'll add 2 and subtract 2. So we can write this as cot theta by 2 plus tan theta by 2 whole square plus 2 into 2a cot theta by 2 plus tan theta by 2 and plus 2a whole square, and it will be equal to 8. Now this is a square plus b square plus 2ab. So we can write this as 2a plus cot theta by 2 plus tan theta by 2 whole square, it is equal to 8, or 2a plus cot theta by 2 plus tan theta by 2, it is equal to plus or minus 2 root 2. And since a is positive and these angles theta by 2, they are acute, we are going to consider only positive values. So this is 2 root 2. Now this is 2a, and if we change it in sine and cos, this is cos upon sine, sine upon cos. So cos square theta plus sine square theta will be 1. So it will be 1 upon cos theta by 2 into sine theta by 2. We'll multiply and divide everything with 2. Now this 2 here will cancel. We'll get this as sine theta. So this a plus cosec theta will be equal to root 2, or this a is simply root 2 minus cosec theta. Now we already know R1 is a tan theta by 2 and R2 is a cot theta by 2. We have to find maximum value of R1 plus R2. So it will be this a and then tan theta by 2 plus cot theta by 2. Now this is a. Now again we'll change it in sine and cos. So it will be this 1 upon sine theta by 2 cos theta by 2. We'll multiply and divide everything with 2. So it will be this 2a sine theta. Now a is root 2 minus cosec theta. So we can write this R1 plus R2 as, now this is 2a and will be this 2 root 2 minus cosec theta upon sine theta, which also is cosec theta. So we can write this R1 plus R2 as 2 and then root 2 cosec theta minus cosec square theta. Now this R1 plus R2 is a function of theta. We have to maximize and minimize it. Now we'll differentiate this. So let this expression be e. So we'll let dE upon d theta will be 2 and then root 2, and cosec theta is minus cosec theta cot theta and then minus 2 cosec theta and then minus cosec theta into cot theta equals 0. So from here we get either cosec theta is 0 or cot theta is 0 or cosec theta is 1 by root 2. Now cosec theta cannot be 0 and cosec theta cannot be 1 by root 2. So the only critical point that we get here is cot theta equals 0. That means theta equals pi by 2. So we have this critical point at pi by 2. Now we have to find sine before and after pi by 2. So what we'll do is we'll take up general point pi by 4. Now cosec pi by 4 is root 2 and cot pi by 4 is 1. So this is 2 into minus 2 and this is plus 4. So this is plus and minus. So we'll have a local maxima at pi by 2. So it is a point of local maximum, and we have to find maximum value of R1 plus R2. So we'll get maximum value of R1 plus R2 if we put theta as pi by 2. So if we put theta as pi by 2, then this R1 plus R2 max, it will be, now cosec 90 is 1, so it will be this 2 into root 2 minus 1. So the maximum value of R1 plus R2 is 2 times root 2 minus 1, which is nearly 0.83. Now this is not greatest linear function. This is integral value nearest to x. This value is 1, and that is the answer to this question. Now here the question is, in a parallelogram ABCD with angle A equals 60, the bisector of angle B is drawn which cuts the side CD at point E. The circle S1 of radius R is inscribed in the triangle ECB, and another circle S2 is inscribed in trapezoid ABED. So here we have this parallelogram. ABCD with this angle A60. If angle is 60, then this angle it is 120. So bisector of angle B will intersect this side CD at E, and this angle it is 60, and this angle will also be 60. That's it. A circle S1 is inscribed in ECB. So we have this circle S1 inscribed here, and we have another circle S2 which is inscribed in this trapezoid ABED. Now it is given that radius of circle S1 is R. So for S1 radius is R, and for S2 suppose it is R1. Now first question is we have to find value of radius of S1. Now clearly this angle is 60, that means this angle is also 60. So this triangle BEC is an equilateral triangle. So if it is an equilateral triangle, and if we join this point here, this is 90, this is suppose its center C1, then this value it is R, and this is suppose P. Now we know that PC1 upon BP it is 1:3. Now PC1 is R, so from here we get value of BP as 3R, and BP is equal to diameter of this second circle. So from here we get 2R1 equals 3R, or R1 equals 3R by 2. That means this A it matches with S. So this A it matches with S. Now this B is value of distance between centers of S1 and S2. So we have to find distance between centers of S1 and S2. Now we'll drop this perpendicular here. This is C2, and we have to find this length. Now this length here is 3R. This is R. So this length here will be 2R, and this is 3R by 2. So 2R minus 3R by 2 is R by 2. So this distance it is R by 2, and say this point is Q. So value of C1Q is R by 2. Now we have to find the value of C2Q and let this point be R. So what we'll do is we'll join this center with B. Now this angle is 60, so this angle will be 30 degrees. Then we can write 1030, it is 3R by 2 into BR, or BR it will be 3√3 R by 2. Now BR is same as C2Q. So from here we can write C1 C2 square it is equal to C2Q square plus C1 Q square. Now C2Q square is same as BR square, so there will be 27 R square by 4 and plus C1Q square, and there will be R square by 4. So this is 28 by 4, 7. So it will be 7 R square. So C1 C2 it is under root 7R. So distance between their centers it is root 7r. That means this D, it matches with R. Now C is length of common tangent of S1 and S2. Now they'll have a direct common tangent as well as a transverse common tangent. So for the C part, we'll calculate length of direct common tangent, and it is given by under root of D square minus R1 minus R2 square, and length of transverse common tangent, that is under root of D square minus R1 plus R2 whole square. Now this D is distance between centers, and that is under root 7r. So here we write this as under root of, and this is 7r square minus, now R1 minus R2 is, now R1 is 3r by 2 and R2 here is R. So if we subtract them, it will be R by 2. So there will be R square by 4. Now this is 28. 28 minus 1, 27, and 27 is 3 root 3 R by 2, and length of transverse common tangent will be under root 7r square minus, now this is R1 plus R2, there will be 5r by 2 whole square, so 25 r square by 4, now this is 28, so it will be this root 3 r by 2. So in this case, they have asked for length of tangent, and the option which matches this option Q. So this C, it matches with Q. And then option D is find the value of length CE. Now C is effectively length of this equilateral triangle. So suppose this length is L, then we know that L cos 30 is equal to 3R. So we get L cos 30 equals 3R, and cos 30 is root 3 by 2. So it will be this L root 3 by 2 equals 3R. Then this L is 2 root 3R. So value of C is 2 root 3R. That means this D, it matches with B. And that is the answer to this question. Now here the question is, a line y equals mx plus 1. So we have this line. Y equals mx plus 1, which intersects this circle at 2 points P and Q. Now center of this circle, it is at 3, minus 2, and its radius is 5. If the midpoint of line segment PQ has x coordinate of minus 3 by 5. So this point, it is minus 3 by 5, then we will find range of M. Now suppose this coordinate is K. Now what we will do is, we will find point of intersection of this line and this circle. So we will put y as mx plus 1. So we will get this equation as x minus 3 square plus mx plus 3 square, and that will be equal to 25. So this equation will be 1 plus m square x square plus 6m minus 1x, and this is 18. 18 minus 25 is 7. So it will be this minus 7 equals 0. Now this equation will have two roots, x1 and x2, and we know that x1 plus x2 by 2, it is minus 3 by 5. Now x1 plus x2 is sum of roots, which is minus b upon a. So it will be this minus 6 m minus 1 upon 1 plus m square by 2 will be equal to minus 3 by 5. Now this minus and minus will cancel. Now it will also cancel, so we get 1 plus m square equals 5m minus 5, or this equation will be m square minus 5m plus 6 equals 0, and we get this as m minus 2 m minus 3 equals to 0. So value of m is 2 and value of m is 3. So m can have two values, 2 and 3. So the only option which contains these two values is this option C.